volcanoes. They're terrifyingly destructive, but they're also the most fundamental force on the planet. Volcanoes are part of a global system that continually reshapes our world. They hold the key to the origins of life on Earth. They saved the planet from the biggest crisis it's ever faced. And they've even formed a partnership with life that keeps our planet habitable. I've come all this way to see one of the most remarkable volcanoes anywhere on the planet. Iain. The name means the smoking mountain to the local Afar people. It's reckoned this volcano has been continuously erupting lava for longer than any other on Earth, though no one's quite sure because it's only been properly studied for the last 40 years. I've been lucky to see a lot of volcanoes in my time, but I've never seen one that has a permanent lake of molten lava in its crater. But there's another reason why this volcano is very special. And to see that, I need to get down into the crater and see the lava up close.
How's that feel?
That's fine. But the rocks here are very sharp and very brittle, so it's actually good that we're on an overhang and that we're not going to actually crash into them.
Okay.
Nervous?
Yeah, a little bit nervous, apprehensive really. You know, it's the first time you're ever going to abseil. You kind of didn't want it to be down into an active volcano, but hey. And then the ledges. So this is my one now.
Sit back, sit back.
After.
Release here. Okay. That's it, that's good.
It's a 30-metre vertical drop to reach a wide terrace below. And the lava lake itself is a little further down. I've waited until sunset to take a closer look because the lava is at its most spectacular at night. This is as close as I can safely get.
Oh wow, look at that. That is magnificent. I mean it's taken us a hell of a journey to get here, but that makes it all worth it. I'm standing on the edge of an active volcano, right next to a big pool of molten lava.
What makes this lava lake more than just pure spectacle is that it's a window that allows us to look deep into the Earth. And it helps us understand the forces that shape our planet. Just take a look at the motion of the lava lake speeded up. Something intriguing is happening. The movement of the lava follows a very distinctive pattern. It wells up on one side of the crater and forms a dark crust as it cools. Then this crust moves across the surface of the lake, driven by the churning action of the lava below. Finally, the crust sinks back down. As we'll discover, this process of molten rock churning away below the surface affects our entire planet. That's because this lava lake is connected to a gigantic source of heat that lies deep inside the Earth.
I think it's fair to say that most of us go about our daily lives completely unaware that underneath our feet, our planet is incredibly hot. I mean, we live on a thin skin of cool rock, precariously located between the cold freezer of space up there and a red-hot furnace down there.
And what a source of power this furnace is. The Earth's heat does far more than just fuel volcanoes. It created the first atmosphere in the oceans. It continually reshapes the planet's surface, builds great mountain ranges, and moves entire continents. And it created the conditions for life on Earth to begin. In fact, you could say that the whole history of the planet has been driven by the massive heat trapped inside it.
To understand where our planet's inner heat comes from, we have to go back 4.5 billion years to the time of Earth's own birth. It was a period called the Hadean, after Hades, the kingdom of hell, which is a good name because this was a hot, hostile and violent world.
You may not recognise it, but this is our planet in its very earliest days. Little more than a few pieces of rock colliding as they circle the sun. These impacts were so violent they generated immense amounts of heat. And they also delivered vast quantities of radioactive material to the Earth. Eventually, when the outer layers of the planet cooled, these two powerful sources of heat were trapped in a huge hot core. The centre of our planet is as hot as the surface of the sun. This is the source of Earth's vast heat energy. And it's what fuels volcanoes to this day.
Trapped within our planet, Earth's hot core has been continuously releasing unimaginable amounts of heat. It gives you some idea how much when you realise that even after 4.5 billion years, there's still plenty left.
Earth's inner heat makes the planet's surface incredibly dynamic. It has created a restless, continually changing landscape, unlike any other in the solar system. It's a world of destruction and renewal. This is Iceland, a place that offers a great opportunity to see exactly how Earth's inner heat is continually reshaping the planet's landscape. Molten rock usually lies hundreds of kilometres underground, but here, as in Ethiopia, it's much closer. Yet the effect is very different. Sulphurous fumes and bubbling hot pools hint at the power that is just beneath the surface. There are naturally heated pools everywhere on the island, which makes going for a dip something of a national pastime.
These hot springs are fabulous for relaxing in, provided you don't mind sharing your bath. The mineral-rich water is meant to have therapeutic qualities. But the people here might not be quite so relaxed if they knew exactly how the water gets heated. Right beneath us is a seething mass of red-hot, molten rock.
Just 20 kilometres beneath Iceland is a vast column of superheated rock, known as a plume. Recently, the shape of this hot plume of rock has been mapped. It's 100 kilometres wide and at least 600 kilometres deep. Created more than 50 million years ago, the plume is sustained by heat continually rising up from the Earth's hot core. But this giant plume of superheated rock has done much more than just warm up Iceland's hot springs. It also created Iceland itself. In 1963, we got to see how it must have happened. A volcano just below the sea's surface blasted its way out of the water. A new island, Surtsey, was born. This is what Iceland must have looked like 50 million years ago when it first burst above the surface. But what makes Iceland so unusual is not just that it sits above a hot plume. This small island is also shaped by the Earth's inner heat in another, much more powerful way.
This is Thingvellir. It's an important place in human history because in AD 930, a group of Icelandic chieftains gathered here to sort out their disputes. This was the world's first parliament, which then sat here for the next 8 centuries. But there's another reason why this is an important place. Although they didn't know it, those early pioneers of democracy had set up their parliament in the shadow of a most extraordinary rock face.
From the air, you can begin to see just how unusual this rock face is. It's a crack in the Earth's surface that runs for hundreds of kilometres. But what we're looking at is just a tiny part of something much, much bigger.
This is the edge of a gigantic slab of the Earth's crust which runs unbroken for 7,000 kilometres. Right from this point, under the Atlantic, across the USA, all the way to California.
It's what's known as the North American Plate. The Earth's surface is broken up into 7 major chunks called plates. They're so enormous that they can carry an entire continent and extend far under the sea. Strip away the Atlantic Ocean and you can see a long boundary between 2 of these plates that runs along the ocean floor until it rises above the waves, cuts through Iceland, to eventually join up with the rock face at Thingvellir. It's possible to see this plate boundary from a completely different perspective. This is a very cold place to go scuba diving. The water's just 4 degrees Celsius. But it's worth it. Because I'm actually swimming in the gap between the 2 giant plates that run through Iceland. To my left, the North American plate, and to my right, Europe. These sheer rock faces were once joined together, but driven by immense geological forces, the land was split apart to create these deep chasms which filled with water. It's hard to imagine a force that can move continents apart. Yet this is precisely what the Earth's inner heat is able to do.